Hello, welcome to lesson 6.3, square root functions and inequalities. So we're going to break this up into parts and we're going to focus on the square root function first, and then we'll deal with the inequalities later on. So this is going to look somewhat familiar, some parts of it, hopefully, as things we've talked about with other functions this year. Now we're going to apply it to a square root function. First, though, let's go look at the parent function. F of x, remember f of x represents y, equals square root of x. So that's your basic, this is as basic as it gets, looking parent function for square root of x. And we're going to do everything that happens to it to this function. Notice it starts at the origin at 0, 0. Now as you look at it, kind of looks like half a parabola that's on its side. And really, that's what it is. Remember, what's the opposite or the inverse operation for squaring? That's right, it's square rooting, or taking the square root of something. It's probably more grammatically correct way to say that. So it stands to reason that the graph is going to look related to it. However, if we had the other half of that parabola turned sideways, so if we had something going down here, then we wouldn't have a function anymore, because x would have to choose where it goes to find its function value. So we only have the positive values. So this is an instance then where our domain is x values greater than or equal to 0. Now, up until now, vast majority of the functions we've worked with and used have had all real numbers for the domain. Now we're going to limit the x values that we choose. And we do that because we don't want to have a negative under the radical symbol. So in the radicand, the thing that's under the radical symbol is called the radicand. R-A-N-D-I-C-A-N-D. Or no, R-A-D-I-C-A-N-D. There we go, radicand. Okay, now, then we also have to talk about what's the range. What are the possible y values or the possible function values? Once again, you look at this, there is nothing below 0. Everything is going up the y-axis at this point. So our range is y is greater than or equal to 0, or f of x is greater than or equal to 0. Next, we can talk about the intercepts, both the x and the y-intercept. So the x-intercept is actually at x equals 0. And we find that by looking and taking what's under the radical, so the radicand, setting it equal to 0 and solving for x. When we find that, that tells us where it actually crosses the x-axis. If we want to find our y-intercept, well, we're looking at the graph, we can tell, of course, or then it's when what value of x makes the function 0. And we're going to practice more of that as we go. Now, the intercept, we did intercepts, not defined, x values less than 0. So you're going to have to say that. And it's not always going to be x values less than 0. You're going to have to solve and figure out what that is. Usually, it's going to be what the x-intercept is. Then we talk about the end behavior. We did that with other functions, polynomial functions. So as x goes to 0, the function value goes to 0. We're going over that spot. As x goes to positive infinity, the function value is going to positive infinity. Now, we're going to spend the bulk of our time looking at domain, range, the intercepts, what the graph looks like, that sort of thing, and how it moves around. That's going to be the bulk of what we're doing. But, we need to talk about the end behavior because we've talked about that previously. Now, in the past, there we go. We've talked about transformations. How does our parent function move? How does it move left and right, up and down? What flips it or reflects it over the x-axis? That sort of thing. And that's what we're going to focus on. We're not going to focus on a horizontal stretch, just a vertical stretch. And then a horizontal and a vertical translation. So, here's your super generic square root function. And the a, the h, and the k, they keep meaning the same things they've always meant. we're going to start with h. H here is going to be under the radical, and x minus h is going to be our horizontal translation. If h units right, if h is positive, or in other words, we're looking at this, we go the opposite direction of the sign. So if it's x minus something, we're going right. If it's x plus something, we're going left. Sounds like what happened when we did quadratic equations as well. So just remember that. What's under the radical tells us how it's moving horizontally. What's outside the plus k? If it's positive, it's going up. If it's negative, it's going down. Now, one hint. Sometimes this plus k or minus k or whatever is written out in front of the radical so that it's very clear that it is not under the radical. So we'll see that in some examples, and we'll clarify what all is happening there. Okay, so if h tells us our horizontal translation, it's going to tell us about our domain. So our domain is going to be x is greater than or equal to whatever h is. So wherever we moved it, that number horizontally, that's going to become our domain. And our range is, if we moved it up, then it's going to be, and it's a is positive, we'll talk about a in a second, then it's going to be it's greater than or equal to k. If it's reflected over the x-axis, so it's a negative, then it's going to be less than or equal to k. Now, a tells us the orientation and the shape. So, if a is less than 0, it's reflected across the x-axis, just like before. If it's negative, flipped over the x-axis. If the absolute value of a is greater than 1, then it's stretched. It's a vertical stretch, and we'll see what those look like when we graph them. And if it's between the absolute value between 0 and 1, then it's vertically compressed, and we'll see what those look like as well. I think they're easier to demonstrate than try to describe in words. But it's the same type of thing that we've been seeing all along with all the functions that we've worked with. Now, quick example. If you're asked to graph a function, y equals 3 times the square root of x minus 4 plus 2, and state the domain and range. So we can find our minimum point, and we know it's a minimum because a is positive, and h is 4, because we go the opposite of what's written under here. So if that's minus 4, we're going to write plus 4, or positive 4, and k stays the same. K is 2. The best way to do this, if you're doing this by hand, is make a table of values. And we say table of values for x greater than 4. There's no need to do anything less than 4 because our domain is x is greater than or equal to 4. Now you're going to have some funky numbers, so just approximate as best you can when you graph. Now, the graph is going to be the same shape as the parent function square root of x, but because a is 3, and that's greater than 1, it's stretched vertically. And it's also going right 4 and up 2. We got right 4, up 2. So now let's take a look at this. Made a table of values, 4, 5, 6, 7, and 8. You plug it into the equation and you solve. You get 2, 5, 6.2, 7.2, and 8. Notice that as x increases, so does y. So our domain is x is greater than or equal to 4 and y greater than or equal to 2 for the range. Plot your points. And notice here's our vertical stretch. It's increasing a lot more quickly. So that's what the vertical stretch does. The vertical compression, it'll flatten it out a little bit, okay? So that's what it looks like to graph. We're going to do a few more of these in another video in the next part. Now, let's look at this one, just so you see what happens when it reflects over the or the x-axis. You'll notice that because we have y equals negative square root of x plus 5 minus 6. And we got to state the domain and range. All right, now let's take a look at this. We're going to make our table of values. We're going to have a vertex, or not a vertex, an endpoint at -5, negative 6. And it's going to reflect over the x-axis, but it's going to go left 5 and down 6 because of the opposite direction there, so the minus 5, minus 6. Let's take a look. So you make a table of values. Now, we want to still get bigger. Now here, you could just pick negative 5, negative 4, negative 3, negative 2, negative 1. Or you pick numbers that hopefully give you whole number answers. That's entirely up to you. I would just pick, a bunch of consecutive numbers, and you're going to deal with the decimals that you get and approximate as best you can. All right, now let's take a look. We've got the endpoint at negative 5, negative 6, and then it's just slowly decreasing from there. But at that normal square root of x kind of curve, because a was just negative 1. It reflected it. Now, one thing I want to note, because I believe we had a small typo here, this should be the maximum point. Make sure you change that to say the maximum point, okay? Other than that, we're going to do a few more examples in the next section and continue to practice finding all these features of square root functions. Thank you.